Hello students, welcome to the topic differentiability. In this video, I am going to solve more number of examples on logarithmic properties. In last videos, you learned that how to use log properties to the function and how to find the derivative if the logarithm base is other than e. In this video, I am going to solve different examples on derivatives of the functions using logarithmic properties. Now let's see the question. If y raised to x is equal to x raised to y, then find dy by dx. Now see, in this example both are function raised to function, left side as well as right side, y raised to x and x raised to y. So to find the dy by dx function, so you have to use log properties. First, write given function y raised to x is equal to x raised to y. Taking log on both sides, it becomes log of y raised to x is equal to log of x raised to y. Now using properties of logarithm, so this power is multiplied to the logarithm. Therefore here x is power of y, therefore x into log y is equal to y into log x. Now this is a simple form, so easily we can differentiate. So differentiate with respect to x. Now left side or right side, these two are product of two functions. Therefore use the product rule and differentiate the function. So you know the product rule. This is the product rule. So keep one function as it is. Differentiate log y. It is 1 by y dy by dx plus log y x derivative is 1. So this is a product rule. Is equal to, in the same way, keep y as it is, differentiate log x, it is 1 by x plus log x as it is, derivative of y is dy by dx. So in this answer we have 2 dy by dx term. So therefore this term transfer left side and take the common, you will get the dy by dx function answer. So therefore what you have to do is log x dy by dx, transfer left side. So it becomes x upon y dy by dx plus log y minus log x dy by dx is equal to y upon x. So in the next step, take dy by dx common and also this log y term transfer right side. Okay, so if you take dy by dx common, what is the dy by dx first term coefficient or neighborhood function? X upon y. So in the bracket you write x upon y. Here the neighborhood of this dy by second dy by dx is minus log x. So write minus log x and complete the bracket. And equal to y by x, transfer this right side, minus log y. So in the next step, we have this equation. In the next step, take LCM in the right side and also in the left side also you take LCM y into log x whole divided by y. X minus y is the LCM. For y same term, therefore same term is written x and minus this term is multiplied to the log x, y log x, equal to, in the right side x is the LCM. So therefore it become y minus x log y divided by x. Now this bracket term, product term, you transfer to right side. Okay, transfer right side. So you will get dy by dx is equal to y minus x log y divided by x whole divided by x minus y log x divided by y. And here this y goes to numerator here by division property, and this denominate this x minus y log x is goes to multiplied to x. So dy by dx is equal to, so y is taken to the numerator and this term goes to denominator, or it is multiplied to x. So it become y into bracket y minus x log y divided by x into bracket x minus y log x. So this is the dy by dx function. Now this is the method of finding dy by dx. Now see the next question. If x raised to y plus y raised to x is equal to 1, then find dy by dx. So in this example, we have addition of two functions. Okay, left side addition of two functions. We cannot take log directly to this. You know, in last video I discussed if you have an addition, how to find the derivative, that is dy by dx function. So first you write given function and denote the first function as u, and second function y raised to x you denote as a v, y raised to x, v is equal to y raised to x. So then given function become u plus v is equal to 1, u plus v is equal to 1. You differentiate this with respect to x. So u is a function of x, v is also function of x. So when you differentiate, it is written as du by dx plus dv by dx is equal to 0. Okay, so now here your work is to find the du by dx function answer, dv by dx function answer. So in that answer you will get a dy by dx terms. Simplifying that, you will get dy by dx function answer. Okay, so first let me find a du by dx function and take this as equation 2. So taking log on both sides for both u and v here, because both are function raised to function. So you will get log u is equal to log of x raised to y, and log v is equal to log of y raised to x. So log u is equal to, using property, this is multiplied to the log x term, that is y into log x. So here x is multiplied to log y. So here you differentiate with respect to x, log u function you differentiate. So this become 1 by u du by dx, and y into log x, use the product rule, y as it is, log x is 1 by x, plus log x as it is, y function derivative is dy by dx. So in this next step, this u transfer right side. So you will get du by dx is equal to u into bracket y by x plus log x dy by dx. So here you substitute u function, it is x raised to y from the consideration. Write remaining terms as it is. So this is a du by dx function answer. In the same way, take the equation 3, in that find out dv by dx. You denote this as a equation 4. Now from equation 3, we have log v is equal to x into log y. So differentiate with respect to x, you will get 1 by v dv by dx is equal to, using product rule, x into 1 by y dy by dx plus log x, x derivative 1. dv by dx is equal to v into bracket x upon y dy by dx plus log x. So this is dv by dx is equal to, v is substituted from the consideration, it is y raised to x. So we will get y raised to x, x upon y dy by dx plus log x. So this is equation 5. Now substitute this 4 and 5 in the equation 2. Now from equation 2, du by dx plus dv by dx is equal to 0. So substitute du by dx and dv by dx from the equation 4 and 5. So that is x raised to y into bracket y upon x plus log x into dy by dx plus this is du by dx. Now dv by dx, y raised to x into bracket x upon y dy by dx plus log x is equal to 0. So now in this equation we have 2 dy by dx terms. So therefore multiply the bracket and then take the dy by dx function. Remaining terms you transfer right side. So you will get dy by dx answer. So therefore first you multiply the bracket x raised to y into y upon x plus x raised to y log x dy by dx plus y raised to x into this first term, that is y raised to x upon y dy by dx plus next y raised to x into second term, that is y raised to x log x is equal to 0. So here dy by dx is common. See here. So this common, put the bracket. So first term coefficient is x raised to y log x and second term is y raised to x into x upon y. Therefore plus y raised to x into x upon y. Complete the bracket. So is equal to remaining terms, they are positive. So transfer to right side, it become minus sign. So therefore minus x raised to y upon x and minus this is the second term y raised to x log x. So now this multiplication term transfer right side, you will get a dy by dx term. So dy by dx is equal to minus x raised to y upon x minus y raised to x log x whole divided by x raised to y log x plus y raised to x into x upon y. So this is the dy by dx function answer. I hope you understood, students. Now see the next question. If xy is equal to e raised to x minus y, then find dy by dx. First you write given function xy is equal to e to the power x minus y. Now here we can take log directly because left side is product and x minus y, it is in the power. Okay, it is not in the base, it is in the power. So therefore we can take a log on both side directly. So taking log on both side, log of xy is equal to log of e to the power x minus y. Now log of xy, it is the product, no? So using log m into n, that is a log m plus log n. So it is written as log x plus log y, it become addition. And here m raised to n property, x minus y is multiplied to log e. And base is also e. So both are same here. Log e to the base e. Remember its value is 1. So therefore we get only x minus y in the right side. Now I differentiate this equation. Log x derivative is 1 by x plus log y is 1 by y dy by dx. X derivative is 1 minus y derivative is dy by dx. So here also we have two term in dy by dx. So transfer left side and non dy by dx term right side. So you will get 1 by y dy by dx plus dy by dx is equal to 1 minus 1 by x. So here you take the LCM and here it is a common term. So dy by dx into bracket 1 by y plus 1 and right side if we take LCM this x is multiplied to 1. So therefore x minus, this is numerator as it is 1 whole divided by x. Now transfer this bracket term right side, you will get a dy by dx function. Or here only first you simplify, take the LCM, y into 1 it is y, this y into 1 y, because LCM is y, and then 1 remains as it is, 1 plus y divided by y is equal to x minus 1 divided by x. Therefore dy by dx is y into x minus 1. This denominator goes to numerator, cross multiply. Okay, when you transfer this, cross multiply, y into numerator x minus 1, and this 1 plus y goes to denominator, that is x into 1 plus y. So this is the dy by dx function answer. Thank you, students.